Hello students, welcome to my video on single inheritance in C++. Let us see what do you mean by inheritance first. The mechanism of deriving a class or classes from an existing class or classes is known as inheritance. So we can derive or create a new class or multiple classes from existing class or existing multiple classes. So this type of process or the mechanism is called as inheritance. In the inheritance, the existing class is known as base class. It is also known as superclass or a parent class. So whenever we are deriving a new class from existing class, so that existing or the old class is called as superclass or parent class, or generally it is called as a base class. And the new class which we are creating from the existing class is known as derived class. This derived class is also known as subclass or child class. So in the inheritance, these are the two main classes. The existing class is known as base class and the newly created class from existing class is known as derived class. So depending on how many number of base classes are there and how many number of derived classes are there and the number of levels, the inheritance is classified into 5 types of forms or types. The first type is single inheritance, second multiple inheritance, then hierarchical inheritance, multi-level inheritance and hybrid inheritance. Out of these 5 types or forms, today we are going to discuss single inheritance. So what is single inheritance? If one class is derived from a single base class, then this type of inheritance is known as single inheritance. So there is one base class, that is the existing class, and from this existing base class, if we create or derive another class, that is a derived class, then such type of inheritance is known as single inheritance. So single class is derived from single base class. So that is nothing but the single inheritance. So while implementing single inheritance in C++, it is required to define base class and derived class. So the base class is defined with a normal class definition. So whatever the class definition we are writing in C++, so similar to that your base class definition will be there is no change. But while defining a derived class, the syntax we have to follow like this: class, that is a keyword, then the name of the derived class, then colon, visibility mode and base class. So here the derived class name you have to mention at the left side of your colon, and the base class from which you are deriving a new class, so that name of that base class is required to specify on the right side of your colon, and then beginning of the class, and as usual in the private section define, and in public section declare or defined member functions, and end of the class. So this is how we can define a derived class. Now in this definition, so this symbol colon is newly used and it is known as relationship operator. So it indicates the relationship between the derived class and the base class. So this derived class is derived from which base class, so that a relationship is indicated by this colon symbol. There is also the visibility mode. So visibility mode, what do you mean by visibility mode? So this visibility mode is nothing but it may be a private, public or protected. So these are the 3 visibility modes that we can use in the inheritance: private mode, public mode or protected mode. So usually this visibility mode is used as public. The details of visibility modes we will see in another video. So currently we can use public visibility mode to define the derived class. So like this Here the derived class is publicly derived from the base class. So that is the meaning of this visibility mode. Now after defining derived class, in main function we are required to create the objects. So while implementing inheritance, the objects are created of derived class. So we have to define two classes, base class definition and derived class definition. But while creating objects, the objects are created of derived class only. The object of derived class can access the member functions of derived class as well as base class. So even though we are creating objects of derived class only, but this object can access the member function of derived class as well as of base class. So it is not required to create the object of base class, only create the object of derived class. This is the syntax. As usual, you have to give the name of the class. Here the name of the class, you have to use the name of derived class and then the name of the objects. For example, teacher T1 comma T2. So here teacher is considered as a derived class and T1 and T2, these are the objects. After creating objects, using these objects you can access the member functions of base class as well as of derived class like this. So accessing member function of base class. So here object dot, and whichever the member function of base class you want to use or call, you can specify its name and provide the arguments if required. Similarly, the same object can be used to call the member function of a derived class. So object dot derived class member function and arguments if required. So like this, here also the member functions are called using the object of derived class. So in both cases the object is of derived class, but the member functions of different classes. That is the base class member function or derived class member function you can call easily even though the object is of derived class. Now let us see one C++ program to implement single inheritance. So this is the problem definition. Declare a class box having data members length, width and height. Derive a class cupboard from box class with data members number of shelves. Write a C++ program to accept and display this data for one cupboard object. So the base class is box, and from this base class box the data members, so the data members of base class are length, width and height. So like this is your base class box, and from this base class box we are going to derive a new class. The name of derived class is cupboard, and there is only one data member, that is shelves, number of shelves. So like this, here the cupboard class is derived from box class, and in this way this is the example of single inheritance. So let us write a C++ program in next slide. As usual, you include the iostream.h header file. Now let us start the base class declaration. The name of the base class is box, beginning of the class. In the private section, the data members are declared length, width and height. These are the three dimensions of any box, and these are of integer type. In the public section, the member functions are declared. Two member functions are declared. One is the getBox and another is putBox. The getBox function will accept the three dimensions of box, that is length, width and height, and putBox will display the three dimensions of box. Let us define the detailed definition of this getBox and putBox one by one. So first is the member function definition of getBox. So getBox is the member of class box, and like this here, void box, scope resolution operator, getBox void, no arguments, no return value. The input operation is performed using scene. So scene length, scene width and scene height with proper prompt messages like enter length, enter width and enter height. Now let us define another member function, that is putBox. putBox is also the member of class box, and hence the definition we start the header line void box, scope resolution operator putBox void. So no arguments and no return value, hence voids are specified. And within the body of the function, the value of length, value of width and value of height. These three data members are displayed with the proper heading. So in this way your class definition is completed with three data members, length, width and height, and two member function, get box and put box. So let us go for now derived class definition. So derived class, the name of the derived class is cupboard and it is derived publicly from the box. So like this, here I am using the syntax, that is a class with a keyword, then name of the derived class is cupboard, and colon, that is the relationship operator, public is the visibility mode, and the name of the base class is box. So cupboard is a class which is publicly derived from the base class box. Now let us define or declare the data members in private section. There is only one data member, shells, that indicate the number of shells in cupboard. In the public section, we will define or declare the member functions. The get shells, it will accept the values of number of shells, and put shells will display the number of shells value. End of the derived class. Now let us define these two member functions, get shells and put shells, outside the class. The first member function definition of get shells: void cupboard scope resolution operator get shells void. So here no arguments, no return value again, and here it is only accepting the number of shells. So display the message to user to enter number of shells, and using scene extraction operator accept the value of shells. So like this, number of shells are accepted using get shells. Let us define the member function put shells. Again it is not accepting any argument and not returning any value, and hence void cupboard scope resolution operator put shells and into bracket void, and here using cout and insertion operator I am displaying the value of number of shells as using the data member shells. End of the function. So like this, the definition of derived class cupboard is completed, and now let us create the object in the main function and call these member functions in a proper sequence. So main program, in the main function anti-main, first of all the first step is create the object of derived class. So here C is the object I am creating of the derived class. Our derived class is cupboard, and I am not creating the object of box class as it is a base class. So always create the object of derived class. So like this, C is the object of cupboard, which is the derived class. Now ask the user to enter the data of cupboard by displaying this message. The first function call is c.getBox. So now the object C is calling the member function of base class. So getBox is the member function of base class. So here this function will accept the length, width and height of the box from the user. After that, the object C is calling the member function getShells. This getShells is the member function of derived class. So like this, object C is calling the member function of derived class this time. So in this way, the object C, which is the object of derived class, is calling the member function of base class as well as the member function of derived class. Then after performing input operation, let us display the data of cupboard by calling the putBox function of base class and putShells function of derived class. So here also the object of derived class C is calling the member function of base class, that is putBox, as well as calling the member function of derived class, that is putShells. In this way, the output operation is performed. PutBox will display the three dimensions of the box, that is length, width and height. And the putShells will display the number of shells of the cupboard. End the program with return 0. If you run this program, the output will be displayed like this. First of all, it will accept the data of cupboard as length, width and height. So here the user entered, suppose the length 3, width 1.5 and height 5.5. Number of shells will be accepted, that is a 6 suppose, and after finishing your input operation, the output operation we are displaying the data of cupboard, that is the length is equal to 3, width is equal to 1.5, height is equal to 5.5 and number of shells is equal to 6. So like this, here the single inheritance is implemented using the base class box and the derived class cupboard, and the object of derived class C. On the basis of this particular video, now you can write your own C++ program to implement the inheritance like this. The class name is employee and the data members are emp id and name. From this base class derive the another class, that is worker, and having data members daily wages. So here you have to define first base class, that is the employee. In the private section declare the data members emp id and name. In public section you define the member function that is get emp and put emp, which will accept the emp id and the name of the employee, and in put emp the both data member values will be displayed. Similarly, you define the derived class worker, publicly derived from the employee base class, and with one data member daily wages in the private section, and in public section you can define the get worker and put worker member functions. Get worker will accept the value of daily wages and put worker will display the value of daily wages. And in the main function you create the object, let us say w, worker w, object of the derived class, and using this w object you call the get emp and get worker functions, and then call put emp and put worker function, and like this you can complete your C++ program. So I hope you will be able to write the complete C++ program and will solve this particular problem to implement the single inheritance. Thank you for watching my video on single inheritance.